Hi there, welcome to the final session or lessons for Module 8. We have been talking about date and time variables using the date and clock functions to produce a variety of products irrespective of how it comes out in the raw form. So we're going to really go through a couple of practicals, look at certain pieces of data, some that you can use straight away, and then hopefully we're able to build clarity about how this is done. So just pay attention to what we are doing because we're trying to tie up all the concepts learned in this module here, and hopefully we should be able to produce very uh, clear information to our clients in the days to come. Thank you so much for your time. I will see you in the practical session where we'll take it up from here. So hi there, welcome to Module 8 Practicals. Now it's going to be a little intense, but I'm sure you're already getting used to it at this level. We've been through, softer or shallow waters in Modules 1 to 7. So we're back to this data set again, this Module 8 students data set. Now it's in the module folder, and also in Dropbox, and you can find it in the link below. So the goals are very simple here. We've had quite a number and we will still tweak quite a number of things, but there are, some additional variables here in this data set. And then I'll go to the question. There's an entry time into the library for each student and an exit time on a particular day. So they took a time. And there's a rule about spending time in the library. So this person, for example, came in at 16 minutes past 9 and left at 13 minutes past 10. There's also record of their payments. First payment in July and second payment in December. So we're asked some questions about the inconsistencies between the first and second payment. And then I really wanted to just show the Excel referencing. Excel, when you format it in Excel, if your data comes in Excel, which is in Excel right now, and it has date of 1, the date it should give you in value is this. Also to emphasize that if you see here, you have date here. We have recorded the Excel in date format. Of course, this is a number format. This is just a general number format, but this is now date. So how to see, of course, when you import it into Stata, how it looks like when you import an Excel date into Stata. We have emphasized that already, but it's good to see it in practical sense. So having gone through this Excel spreadsheet, like I said, it's just M to R that is our concern for this module. We've played with the other ones in the other modules, and we may still be doing some more playing in the next module, which is the final module for cleaning. So we want to do investigation, want to see logical inconsistencies. That's the reason why we are still here. This is literally the third or fourth module where we are still considering logical inconsistencies, and time variables give us a lot of information about that. Okay, without wasting much time, we go now to the question. What are we supposed to achieve, and hopefully to help us understand how to go about this. So this is the question for today. If you have gone to the other modules and you have done other modules, these are the questions for previous modules, but the focus are questions number 10 and 11. How many students spent more than 1 hour? Sorry, not minutes. This is an error. They show 60 minutes. More than 1 hour or 60 minutes in the library. How many students have inconsistent payment records? Just 2 questions. And then I'm hoping that these 2 questions will help to summarize and expand on the knowledge you have gotten in the last 6 lessons or so in this module. So we'll put these questions and we'll come back to it shortly. How many spent more than 1 hour? So yeah, we have to investigate. So basically you have to have a strategy, so definitely if you want to find out those who spent more than an hour, we need to go here again. So we need to know when they entered and when they exited, and of course exit time minus entry time will give us the number of hours they must have spent. And then we now know those who are above 60, maybe it's against the rules or whatever. And of course payment too, we have to find out the differences between the payments and see what is the inconsistency there. Okay, so I think we now need to move to Stata quickly and take 12-hour windows. Now, if you have been working along with us all this while, let me, so if you have been working with us all along, this is very important that we have this grid. We have this data all listed out. So basically, the do file here has the previous work we had done. So we're not going to go there. We have gone to append, we've gone to merge. So I'm not going to go through all that. Please, if you have no knowledge of this, you can go quickly back to, I believe, module 6. Go to the practical sessions there. So it's basically the same file, only that we have additional variables which I just showed some minutes ago. So I'm not going to waste so much time there. So basically, each of the sheets in the Excel has been saved and added, and then value labels and all that. So we start our work below line 46. And the work, actually, let's browse first and see what the data looks like when it comes into Stata. And that's the first thing I want to emphasize. If you recollect, there was an Excel reference. And you can see it here, 1st of January, it comes in as a date. So the first thing we want to establish, which we have established theoretically, is that when you have an Excel date, so very clear that when you have a date in Excel and you put it into Stata, everything works perfectly. But I will also try to emphasize that this reference date, even though it produced this date, if you are not careful, you may find yourself in deep trouble just trying to convert it. So let me start with that. So the variable there is Excel reference here. So I'm going to drag it down here and go to format percentage TD Excel reference. Let's see what happens. Format, and now TD means date. The D portion means date. The C portion means clock, which we are going to do shortly with the entry and exit into the library. So let's format. Now C. We have formatted. This gives us January 2nd, 1960. But in Excel, they were the same thing. In Excel, they were exactly the same thing. That was, one was a number and one was a date, a number converted to a date. So if you don't take note of that difference, there will be a problem and a challenge. So what I can do here is say generate Excel reference 3 equals to Excel reference minus 21,915. You give a negative symbol and then you format this way. So let's look at that. That means it's going to generate a variable just after here. So let's do that now again. So we run it again, and then so you can see when I subtracted 21,900 from the Excel value, it gave me the same exact value for this. So this and this are exactly the same because of that difference. I hope now you understand what I was trying to illustrate in the presentation I had, I believe, in lesson 2 or 3 of this module. That's what I'm trying to explain. You have to be careful and know the source when you are given a number. Okay, I think we can leave this and now move on to the other objectives. The first objective was that we needed to find out those who spent an hour, more than an hour. Now, just to show you again what problems arise when you cannot convert into the proper format. So I could just say exit time minus entry time, and then run. Now, if I check into the results window, let me call this difference. Gen difference equals, I need to create another variable, equals to exit time minus entry time. Now, when you do that, it says type mismatch. You're not supposed to be doing a calculation with a string. I just did that to deliberately show you that we now need that conversion, and I emphasize that in lesson 1 of this module. Very important that we have that clearly written out. Okay, so it's clear we cannot use these two variables except we do some form of processing. So we don't waste much time. We take a look at the variables again that we want to deal with. So there are two, the entry time and we have the exit time. Those are the two that we have here. So let's start. So we're going to generate, so we can call this is wrong, so I take it out. Line 49 is wrong, and I've shown you that. I'll call this entry time. Just drag it. Entry time. Sorry. Entry time 2 equals to date. No, sorry. Clock. I want you to see this live. Clock. And what clock am I referring to? Entry time. Not. And then what is the time mask? Or time mask? Yes. What's the mask for this? So we have the hour, the minutes, and the seconds. So that's how we generate it. Now for time, I've told you that you use double. Please go back and check. So that's how we do entry time, and then we run it again quickly. Let's go to the end of the line. So this is what it gives us, a very long form stuff there. So that's it, basically, very long form stuff. The same thing is, I'll just copy the same principle and do it for exit time. Exit time. Exit time 2. Is that clear? And exit here. So we run this again. So it gives us a funny number. Like I told you, this number is the number from midnight 1960. So please go to lesson 2, go through everything we had mentioned. Oh, sorry, lesson 1 of this module. You'll find the theories of this explained. So this is a reference point from midnight of January 1st, 1960. Now, of course, this looks so ugly. You can't make any sense out of this. Really, you can't. So let's see what we do. We now need to format. So we format percentage TC, and I said C is for clock, and these are the two variables right in front of us that we want to format. Let's take this, copy and paste this. So the entry and the exit time too. When we format them, something interesting happens. So you see, it gives us the time. So I could try and compare now. Let's just try and compare. It will give us the time here. This is 9:16. This is 10:13. Let's go there. 9:16, 10:13. But one thing it did, which I was trying to emphasize in the theories I taught in that's for string, yeah, in lesson 2 and 3, is that it gives you a combination. It gives you a reference point. That's the date. It gives you 1960, even though that must have not been the date when they went into the library. But so that it can be able to resolve it in its head, it requires date to be part of time, or calendar to be part of time. And this helps us to do even the subtraction. So let's now do the difference. So we can say gen time spent underscore library equals to minutes. Exit time 2 minus entry time 2. So let's go ahead and see what it gives us. So this is what it gives us. We have 56, 147, and blah blah. Now this is the number of times in minutes, and you can try and do one manually. Pause the video. Let's pull this back a bit. Find out the difference in times between this function and this time and see whether it works. It's just straightforward, nothing hidden, everything is clear before you. Look at any other line. It doesn't have to be the line at point 10, 18, that tells you in minutes. Now for anybody to have spent more than 1 hour, those are people whose time spent in library is more than 60. So 76 people out of 100 spent more than 1 hour in the library. So that's how it works. I hope this is very clear. I hope you are getting value and you're able to now understand why we must first convert. If we don't do 49 and 50, we can't do 52. Of course, even 51 helps us to see because the numbers were odd. It was looking really crazy. And then 51 gave us some, gave us some garnishing. We're able to now understand and identify what's going on. And then we're able to do 52, where we do the extraction of time, differences in time. And we have seen those who have spent over 1 hour. So that's how that is solved. So the next question was actually about, let's go back there to Microsoft Word again. It says, so we've answered this question. So we can say here 76 students. Here. Now, how many students have inconsistent payment records? That's interesting. So let's look closely. And this is where, we look at the logic. So the first payment came back in September. Apparently, everything seems to be in 2020. The year 2020. Second payment in April. Now, that's funny. That's funny. You can't make your first payment in September and second payment in April. Date for first payment, Jan first pay, that's what I'll call this, is equal to date function. And then I put first payment here because I want to extract a number. And then I put the date mask. This comes with month, day, and the year 20. Why? This is the format. You must learn these formats well because they will greatly help. So I'm going to apply the same principle quickly for second payment. So I could also do here, anywhere I see first, please replace it with second and only in the selection, just to make my work faster. So second pay equals second payment. Now we have to be careful. So I've almost made the mistake here now. Second payment, the day comes before the month. So could have made that mistake and I'll get problems for myself. So someone will be saying, what happens if you make that mistake? I would love you to experiment it yourself. Sometimes I don't answer the questions because I want you to see the pitfalls and then recognize. And you can discuss in comments what you found if you swapped it the wrong way. So this one has month and day and year. This one has day and month and year. Like, you swap between day and month. So let's do that now. So we can run. Now when we run it, it gives us first pay. I think there's a problem with second pay. Let's check what the problem is. Oh, second payment not found. Let's see whether the name variable was wrong. Okay, there was a problem with proper case. I taught you that in module 1. Make sure your date is properly done. So we should have a second pay okay and fine. So it's there now. And how do we know? We go to browse mode again. So there's first pay, and I told you this number you just saw is a reference of number of days from 1st of January 1960. So there are a few things you can do. You can go ahead and do this now, comparing those who had inconsistent payment, where their first payment is larger than the second payment. What I just mean is that the value of number of days is more. That means it's a later date. First payment should be a earlier date than second payment. So if first payment is a later date, it's an inconsistent payment. So I can do this, but I would love to have something that is visible. It's really able to export to Excel. So I'm going to come here quickly. I'm going to format. Uh, yeah, where's it? Where's percentage? Sorry, I'm looking for percentage on my screen. Where did percentage go? Sorry, TD, date. I said once you are using date, it's TD. When you're using clock here, it's TC. So TD first pay and then second pay. So let's do that too. So it gives us some, clarity. That's all 58 line 58 does now. So now that we have first pay and second pay in the format that they should be, the next thing we really want to do is now try to see the difference. So second pay, so gen difference, second pay minus first pay, sorry, gen difference equals, let's say, days difference equals second pay minus first pay. So let's quickly run that out so you can see. So second pay is supposed to be greater than first pay. So anywhere where we have anything less than 0, and let's look at this. First payment in September, second payment in April, first payment in February, second payment in January. That's why we have the negatives. Anywhere we had negatives, so we will browse if days underscore difference is less than 0. So let's see what we have. So there are 49 inconsistent payment records, basically. So that's how we investigate, and we can see inconsistencies. Now, how would we have found these inconsistencies if we did not put time and date in the proper formats? So I hope this has been very interesting. I hope you have learned enough, and hopefully you will be able to apply this in very many situations. Trust me, you are just scratching the surface. There are so many interesting things you can do when you know how to manipulate date and time. So thank you so much for your time. I will see you in the next lesson. Bye for now. Oh, sorry. Next module where we'll be talking about cleaning. And I'm so excited because that's the critical video for helping you to really now perfect the data and prepare it for analysis. So see you in the next module. And that's really the second to the last module. And hopefully we'll be able to, build all your confidence, and you'll be able to face any data in the world, understanding the principles we have taught in this course. Thank you so much. See you in module 1, module 9. Thank you. Bye.